Greeting, ladies and gentlemen. Today video I'm going to answering question number 14. 0.5 meter cube rigid vessel initially contains saturated liquid vapor mixture of the water at 100 degrees C. The water is now heated until it's reached the critical state. Determine the mass of the liquid, water and volume occupied by the liquid in the initial state. So the system is just simple. We have a very confined container. In it we have water that been heated up. The initial temperature that will be 100 degrees C. The condition of the water at initial there will be saturated mixture. The volume for rigid vessel will be 0.5 meter cube. After a while, the system will in critical state. This means it have a constant. It is constant value for pressure, constant value for temperature, constant value for specific volume. So critical point, it is defined as the point at which the saturated liquid and saturated vapor state are identical. So this article I retrieved from the thermodynamic book by all of these good person right here. It is very a good book in discuss about thermodynamic. I like this book. But anyway, if we draw the saturated graph, the very top of it, that point we call as critical. It is mean the value for volume, specific volume, in the form of gas and in the form of liquid were identical, were equal. If you doesn't believe me, if we go through to the table A4, at the very bottom of the list, at temperature 373.95, approximate equal to 374, you will define that the VF and VG were identical and indeed the same. So instantly at this point, all of the water in the form of liquid were transformed into vapor instantly. So that is what the at least it is for me, this article were trying to say. And they have at this point the pressure will be 22.06 megapascal. The temperature will be equal to 373.95 degrees C, and the specific volume will be 0.003106 meter cube per kg. So this value we're going to use in our calculation. So this is the saturated line. The initial condition will be at 100 degrees C. At the final condition, they will be at the critical point. Because the system were enclosed, there is no mass in and out of the control volume. Been asking what is the mass of the liquid. So this means it doesn't matter if we make an analysis at the initial condition or final condition, we will define the same magnitude of mass. Let's say that we want to make an analysis at MF. M final, in here is mean M final. M final equal to the specific volume for final over by it is volume, the power of -1. So we know that the critical point, the specific volume, that will be equal to 0.003106. We over it by 0.5. Let's say that the volume for the water at the final condition, it is equal to the volume of rigid vessel. Let's say that. So 0.003106 meter cube per kg over by it is volume 0.5 meter cube. You can cancel out the value of meter cube right there. Then you power of it by -1, so that you can lift up this kg to upper side of the equation. Thus you will get the value of mass at final condition. It is final condition, were 160.9788 kg, and yes, indeed it is the mass in initial condition also. Question will be asking what is the volume occupied by liquid at the initial state. We know that the initial state, the condition of the water were in saturated liquid vapor. This means some of the water were in liquid and some of it in the form of vapor. in this question, it's asking what is the volume in the form of liquid. To answering this question, obviously we need to make an analysis at the initial condition. So we will be using, since that the first in the initial condition were insaturated. So we will use this equation V average equal to Vf plus by X Vfg. X in here is mean humanity, or what we call it, quality. Vf in here is not the specific volume in the form of final, no. It is the specific volume in the form of liquid. Yes, indeed, it is the V bar. It is mean specific volume. It is not volume, it is specific volume. So let's say that at initial, water volume were equal to volume of the container. From my logic, it doesn't make sense because the rigid vessel have a volume of 0.5 meter cube. Meanwhile, it is contained at initial condition saturated liquid vapor. It is mean some of the liquid were in the form of liquid, some of the water in the form of liquid, and some of the water in the form of vapor. In my logic, if we have a container, it is volume will not gonna reach 100% of the rigid vessel volume. It is my logic because some of the water were in liquid and some of the water were in vapor. So this means it must be a void which no atom, water atom in it. So the volume at initial condition, it is heavy to me to say that the volume equal to 0.5 meter cube. But this is the only way that I find to solve this question. I need to classify that the initial water volume were equal to 0.5 meter cube, were equal to volume of the container. But anyway, specific volume in the form of average equal to specific volume in the form of fluid times by the X times by specific volume FVG. We can define the value of Vf and Vfg by table A4 at 100 degrees C. And 100 degrees C. You can find Vf equal to 0.001043, Vg equal to 1.6720 in the form of meter cube per kg. Where is the problem solving? And the Vfg, it is just Vg minus by Vf. This value 1.6720 minus by 0.001043, you will get 1.67. This will be 20 if I'm not mistaken, times by it is quality. Then you will get the quality equal to 1.2178 times by 10 the power of negative 3. Vi, you need to divide by m so that you will get the specific volume, because the unit of specific volume equal to meter cube per kg. So that's why I divide the initial volume by its mass. So you will get the X will be equal to 1.2178 times by 10 to the power of negative 3, the quality. We know that the quality is equal to mg, mass in the form of gas at initial condition, by the mass total. So you will get mg, mass total that will be equal to 160.9788. You times it by the value for quality, you will get mg equal to 0.196 kg. Then we're going to derive another equation. M total at the initial condition equal to m mass of the water in the form of liquid times by the mass of the water in the form of gas. If I tend to find out what is the mass in the form of liquid, we need to minus mass total by mass in the form of gas. So 160.9788 minus by 0.196, we will get 160.7828 kg. So that is the mass of the water in the form of liquid at initial condition. The question asking what it is the volume occupied by the liquid. So we can find it by times this mass by the specific volume. We know that from the table, the specific volume in the form of liquid equal to 0.001043, which is in here. We times it by the mass of the water in the form of liquid, 160.7828. You can cancel out the value of kg right there and leave out with meter cube. The answer will be approximate equal to 0.166 meter cube. So it is close to this value. And the value for kg, that will be different a little bit from me. I get 160.7828 kg. Meanwhile, this will be 158.28 kg because maybe, I don't know, what is the constant value for critical pressure, critical volume, specific volume that the answer using. So it is depend on what is the magnitude that we were using for critical state. So anyway, I think that's all for today. Thank you for watching and have a nice day. Bye bye.